All right, hello ladies and gentlemen, this is Mrs. Masteller and we're getting into our last section of chapter 4, which is 4-7, and this has to do with transformations of quadratic graphs. So there's a second way you can write a quadratic function, and this is called vertex form. So we're familiar with standard form, so just to kind of refresh standard form, I'll write it over here. So standard form of a quadratic is just ax squared plus bx plus c. But now there's a second way you can also write it in vertex form. So here's what vertex form looks like. It is y equals, or f of x equals, same thing. It'd be a inside parentheses is x minus h squared and then plus k, which should actually look very familiar because back when we did absolute value functions, so absolute value functions, again, the form was this. So the only difference is that you have absolute value around the x minus h versus now you have parentheses and it's also being squared. The quantity x minus h is being squared, which again is going to make it into a parabola. So again, this was for a parabola, but this was for absolute value, which of course makes that V shape. So V shape facing up or V shape facing down. Okay, so again, very, very similar idea. And the reason why it's called vertex form, so the y equals a times the quantity x minus h squared plus k, is because your vertex is actually in the form right now. It's your h and your k value, just like before. H and k, h is the x coordinate, k is the y coordinate of the vertex. Okay, but even more so, h and k, they do something to the function. Okay, all those variables, the a does something, the h does something, the k does something. So let's just kind of refresh. What does each of these values actually do? So the k value is going to move it either up or down. Again, it just depends if it's positive or negative. So it's just going to translate either up or down. Goes up if it's positive. It's going to go down if it's a negative number. And then h is going to move it. Again, the way I always remember it, h like horizontal. So h for horizontal, horizontal meaning left or right. So it's either going to move it to the left or to the right. Again, depending if it's positive or negative. So it's going to go to the left if it's negative, goes to the right if it's positive. So just use kind of logic, your common sense when you're thinking about that. A is going to make the parabola either compress or stretch. And it all depends on that A value. It's going to compress or stretch. So if A is a small number, so what do we mean by a small number? If A is a number less than 1 but bigger than 0, so just think of a number that's between 0 and 1, so something like 1/2. So we're talking about a fraction, okay, but a fraction like 3/2, although it's a fraction, that's actually bigger than 1. So again, you're thinking about a number between 0 and 1, something bigger than 0 but less than 1. So like 1/2, or you can say 1/3, or you can say 3/5, or anything like that. But if it's a small number, like I said, any type of fraction, this is actually going to compress the graph. So it's going to vertically compress it. If it's going to vertically compress it, that means it's going to horizontally stretch. So it's going to become much wider. Okay? So you can put that inside parentheses. If it's going to compress, you should see it get wider. If A is a big number, so if A is a number bigger than 1, then it's going to actually stretch the graph. We're going to see it get much narrower. It'll be much narrower or skinnier. You can think about it like that. So if A is a number bigger than 1, so if it's like 2 or 3 or 4 or 5 or anything like that, again, you should see it stretch. Okay? The parent graph, so let's go through this real quick. The parent graph is basically, again, the simplest form of a function that we have. So the simplest parabola that we can possibly graph where nothing's being done to it is just y equals x squared. Okay? Where the vertex would technically be the origin, just like it always is. Okay, that's always kind of your point of reference. So if you wanted to, you can kind of throw a table together. Again, the vertex would be 0, 0, and then just picking numbers around the vertex. So that'd be like 1, -1. So if you plug these numbers in for x, if you plug in like 1 for x, 1 squared, well, that's just going to be 1 for the y. If you plug in -1 for x, so -1 squared, that's also +1. And then if you plug in maybe like 2 and -2, so our next 2 points we have -1, 1, +1, 1. But now our next 2 points, when you plug in 2 or -2, so 2 squared, your y is going to be 4. -2 squared is also going to be 4. So these last 2 points going over 2, up 4, back 2, up 4, this would be your parent function. So it starts at the origin basically. Okay, so it's not going left or right, up or down, it's not being stretched or compressed, it's not being flipped, all that stuff. Okay? There's one more thing I want to add to, actually, let me just kind of backtrack here. If A is a negative number, so if A is a negative, I want you to add this, it's going to flip the graph upside down. So if it's negative anything, if it's -1 or -1/2, or if it's -2, if it's negative anything, it's going to flip the graph altogether. So A actually kind of does three things altogether. So if you want to add that additional one, it's going to also flip it. Okay, so what we're going to do is we're going to practice now. We're going to go from standard form, so looking at these functions, they're all given to you in standard form. We're going to write them in vertex form and then just identify the vertex. Okay, there's a couple different ways you can go about these problems, but what I would like to teach you guys, let's just think back to the basics here. Go back to basics. Think about when we were graphing a parabola. How did we find the vertex? Okay, well the vertex was found, if you wanted the x-coordinate, you just did -b over 2a. That's the x-coordinate. And then to find the y-coordinate, you just plug that number back into the problem to solve for the y. Okay, so if you identify what A, B, and C are, A would be 1, B would be 16, and then C would be -12. Okay, so my x-coordinate for my vertex, again, is just going to be -b, so -16 over 2 times A, so that's -16 over 2, which is -8. Okay, so far my vertex, we have -8 for the x-coordinate, now we have to solve for the y. So again, all we have to do is take -8, plug it back into the original function. So the y-coordinate, f of x, is just going to be -8 squared plus 16 times -8 minus 12. So it's going to be kind of a big number if you look at these numbers plugged in. That's okay, we can manage. So we get positive 64, and then 16 times -8 is going to be negative, let's see, that should be 128 minus 12. So 64 minus 128, that's -64 minus 12, and -64 minus 12, you get -76. That's the y. So we got the x-coordinate, we got the y-coordinate, this would be my vertex. But how would that look now in vertex form? Okay, so if you put these where they're supposed to be, again, this is your h, and this is your k value, technically. So when you plug these into vertex form, you're going to have y equals, okay, your a value is 1. So if you want to write that out front, you can. You could put the 1 here. And then you'd have x minus your h. So that'd be -8 squared. And then plus your k, but since it's negative, we're just going to say -76. All right, so let me just fix this now. So I don't want to leave it minus a negative. I don't want to do that. So instead, I'm going to fix this. Again, I don't really need that 1 out front, so I'm just going to leave it off. But I'm going to make this into x plus h, quantity squared, minus 76. And that would be your vertex form. Okay, so pretty neat. Got the vertex, you put into vertex form, there it is in vertex form. Okay, one more thing I want to add to this too is I want you to describe the transformation. We're going to also describe the transformations that we see. So because our h value for this first problem, our h value was -8 and our k value was -76. So h again is going to move it. So if you go back up here, h moves it left or right, depending if it's positive or negative, and k moves it either up or down, again, depending if it's positive or negative. So since h is negative, it's going to move it to the left 8 units. And then since k is negative, it's going to move it down 76 units. Okay, and that would be us describing the transformation. That would be it. Okay, so let's try number 2. So starting off again, I'm just going to find the vertex. So our a value is 1, our b value is -2, and our c value is 4. So our vertex, the x-coordinate is going to be -b, so -2 over 2 times 1. So that's 2 over 2. That's just 1. So for our vertex so far, again, we got the x-coordinate. We know it's 1. Okay, now find the y-coordinate. The y-coordinate, just plug 1 back in. So you're just doing 1 squared minus 2 times 1 plus 4. So 1 minus 2 plus 4, -1 plus 4, jumping ahead of myself here. Negative 1 plus 4 is just going to give you 3. So the y-coordinate comes out to be 3. Okay, so we got the vertex. Now write this in vertex form. So the things that we need again, we need h, we need k, and we need a. A value is 1. So using h, using k, using our a value, vertex form would be y equals, again, since a is 1, we don't really need that. So I'm just going to go ahead and skip over that. H is 1, so it's going to be x minus 1, quantity squared. And k is positive 3, so it'd be plus 3. So this would be our vertex form. Okay, now describe the transformation. So because h is positive and k is positive, this would be moving to the right 1, and then it'd be going up 3. So h moves it left or right, k moves it up or down, so it'd be right 1, up 3. All right, so let's try the next one. I'm looking at this guy. So again, starting off finding the vertex, our a value is 2, our b value is 12, our c value is 4. So our x-coordinate is going to be negative b over 2 times a, so that'd be negative 12 over 4, which gives us negative 3. So our vertex so far, vertex, we got negative 3 for the x. Now we need to solve for the y. So plug negative 3 back in. The y-coordinate would be 2 times negative 3 squared plus 12 times negative 3 plus 4. Okay, so evaluating, this would be 2 times 9. This would be minus 36 plus 4. So that'd be 18 minus 36 plus 4, which would be negative 18 plus 4, where we get negative 14 for the y. So negative 3, negative 14, that's our vertex. Okay, so now writing this in vertex form, we have our h, we have our k, we need our a, which is actually 2. So plugging this into vertex form, it's going to be y equals, you'd have 2 x minus negative 3 squared minus 14. So plus negative 14 or just minus 14 in the back. So just kind of cleaning this up, this would be y equals 2. I'm going to change that to be an x plus 3 quantity squared minus 14. But this would be our vertex form. Okay, so now identifying, trying to describe the transformations that we see. So h is negative 3, k is negative 14, and don't forget about that 2 out front, what that 2 is doing. So what the 2 is doing, because our a value is bigger than 1, it's going to stretch it. It's going to stretch by scale factor 2. It's going to go to the left 3. So because 3 is negative, it'd be going to the left. And then k is negative, so it's going to go down 14. So that would be all the transformations altogether. Okay. Last one, number 4. So again, a, h, and k. A is 3. Or I'm sorry, a, b, and c. A is 3, b is negative 18, c would be 10. But finding h and k, finding our vertex. So the x-coordinate again is negative b. So it'd be negative negative 18 over 2 times a. So 2 times 3, so 18 over 6. So it looks like we get 3 for the x-coordinate. So our vertex so far, we got the x, we got the h value, that's 3. All right, plugging that back in. Now for the y, you'd have 3 times 3 squared minus 18 times 3 plus 10. So that's going to be 3 times 9 minus, that'd be 54 plus 10. So that's 27 minus 54 plus 10. That's negative 27 plus 10. So now I'm just going from left to right, where the y comes out to be negative 17. So we get 3, negative 17. That's our vertex. Okay, so now in vertex form, we got the vertex. Again, this is h, this is k. We need a as well, which is 3. So this would be y equals, you'd have 3 out front for a, x minus 3 squared minus 17. There's our vertex form. And then just describing the transformations. Again, you got a, you got h, you got k. So the a value, again, since it's 3, it's a number bigger than 1. It's going to stretch it by 3. It's going to move to the right 3. So because h is positive 3. And then it's going to go down 17. And that would be all of our transformations. Okay? So again, should be somewhat familiar. The only difference now is we're dealing with parabolas. All right, so on to the next page. What we're doing on these next ones, it says to match the functions listed below to the correct graph. So we have 6 options up at the top, A through F, but we obviously only have 4 graphs. So 2 of them we're not going to use at all. Okay, the easiest way to match these up, find the vertex first. So the vertex, this parabola over here, looks like from the origin goes back 1, down 3. So right here, that'd be -1, -3. So I'm looking for these equations. I'm trying to find which one has a vertex of -1, -3. There's only one of them. E. This one right here. It's got to be E. Can't be anything else. So again, H is always opposite as you see it. This is technically -1, and this would be -3. So H is opposite, but K is exactly as you see it. Okay, so look at the next one, the vertex. So right down here, looks like it's at 1, -3. So again, scanning through which one has 1, -3. Again, there's only one, it looks like. It'd have to be F. You could see too that the graph is much wider than a typical parabola, and that's what that 1/2 is doing in the front. So as we already said, it's going to compress it vertically, which means it's going to stretch more wider, or stretch out wider, not more wider, but wider horizontally. Okay, so the next one, notice that it's downward facing. So that's going to eliminate 2 options already. Since it is facing down, it's got to be either B or C. So let's see, the vertex is at 1, 3, looks like. So that's our vertex. Well, they both have a vertex of 1, 3. Okay, so the question is, it is downward facing. Is it getting wider or is it getting skinnier? To me, it looks skinnier, it looks more narrow. So what's going to do that? What's going to vertically stretch it to make it more narrow would be this guy right here. It'd have to be B in this case. Okay, and the last one, it's upward facing, so it can't be C. I can eliminate that one. But the vertex goes, I know it's a little bit lumpy, but it's at -3, -1. So which one has -3, -1 as the vertex? It'd have to be answer D. Okay, so that's how you do that. So again, find the vertex first. Hopefully that'll eliminate some options, if not all of them, and then just take a look at the graph from there. Okay, now we're going to graph the function given to us in vertex form. So the vertex to number 6 would be 3, -1. That's the vertex. All right, so in our table, I'm just going to set this up. We got 3, -1. Again, that's the vertex. Then just pick numbers around the vertex, right? Okay, even more so, we know it's not being stretched or compressed. Nothing's really happening because we have no A value. It's technically just 1, but you just plug in a couple extra numbers, maybe just do 4 and 2. So if you plug in like 4 for x and solve for the y is just going to be, you'd have 4 minus 3 quantity squared minus 1. So that would be just 1 squared minus 1, so 1 minus 1. So you get 0 basically. And you should get 0 also for 2. So again, once you know what the vertex is, you should be getting the same result on both sides. So if we graph this out, 3, -1, going over 3, down 1, we got 2, 0, 4, 0. This would be our parabola facing up. And then this would be your axis symmetry, and straight down the middle. Okay, I also want to throw on here domain and range. So if you had to find the domain and range to this function, again, domain still never changes. It's still always going to be all real numbers. You could plug in any number you want to for x. There are no limitations. I can keep adding as many points as I want to this table. I can do 5, I could do 1, I could do 6, I can do 0. I can keep adding as many x's as I want. So that's never going to be affected. It will cover every single possible x that there is in existence. But the range, our y's, so again, ignoring the dotted line, just looking at the parabola, our y's start here at the vertex, which is -1, and then it's all growing upward from there. So -1 is the starting point, it just keeps increasing, so it'd be from -1 to infinity. And there's our range. So number 7, vertex, so our h and k value, the vertex would be -1, 2, so again, -1 is our h, +2 is our k, so -1, 2, could throw this in our table. I guess I don't need to make it that long. But -1, 2, there's our vertex. So I'm going back 1, up 2, there's the vertex. Throwing some extra numbers here, so maybe you want to plug in like 0 and then -2. Okay, so if I plug in 0 for x, the y is going to be 0 plus 1 squared plus 2. So that would be 1 squared plus 2. So that's just 1 plus 2, and you should get 3 on both sides. So we get 0, 3. We get negative 2, 3. So here's our parabola. Again, axis symmetry. And then just to throw it on here, domain and range. Domain is still all real numbers, but the range this time, where does our range start? Starts here at the vertex, which is 2, and then it just keeps increasing from there. So positive 2 to infinity would be our range. Okay? Next one. I do see that negative out front, which we'll talk about that in a second, but our vertex looks like it would be positive 4 and negative 4 is our vertex. So again, in our table, we got 4, negative 4, that would be our vertex. So just like before, that A value doesn't have anything to do with our vertex. Nothing at all. Okay, but we got our vertex, so going over 1, 2, 3, 4, down 1, 2, 3, 4. Okay, that negative out front, though, is going to make this downward facing. So that vertex that I just graphed right there, that's going to be the highest point on our graph. Everything else is just going to fall underneath it. So if I plug in more numbers, maybe like 5 and 3, if I plug in 5 for x, the y is going to equal, you'd have negative 5 minus 4 squared minus 4. So that would be y equals negative, that would just be 1 squared minus 4. So 1 squared is obviously 1, but that negative makes it negative 1 minus 4, which gives you negative 5. So like I said, the next points will all be underneath that vertex, if that's going to be my highest point. So when I graph my last few points here, if I go over 3 and then down 5, that'd be right here. Over 5, down 5. So this would be your downward facing parabola. And again, axis symmetry, running through it. Domain is still all reals. The range is a little different this time though, because it is downward facing. Technically it starts all the way at negative infinity, and again it works its way up to the vertex is where it stops. So right there is at negative 4. So this one would be from, let me fix this real quick. So this would be, again, from negative infinity up to negative 4 with a bracket around the negative 4. Okay, last and final one, our vertex. All right, technically, if you need to see it, I can rewrite this to be negative 3 x squared like this and then plus 4. So basically what I'm trying to get to is that you don't have an h value. There is no h value, which means your h value would just be 0. So as far as our vertex goes, it'd be 0, comma 4 as our vertex. So again, in my table, I'll just put 0, 4. There's the vertex. All right. So 0, 4, 1, 2, 3, 4 right here. All right, and this one is downward facing again because you have that negative a value out front. So that's going to be the highest point on our graph is 0, 4. So when you plug in numbers around the vertex, maybe you just want to do 1 and negative 1. So if I plug in 1 for the x, as I plug in 1 for x, I'm going to have y equals negative 3 times 1 squared plus 4. So it'd be y equals negative 3 times 1 plus 4. So that's negative 3 plus 4, and that's just going to be positive 1. So this one's going to be a little bit more stretched as well. So not only will it be flipped upside down, but it's also going to be a little bit more stretched because you do have that 3. Okay, that 3 is going to stretch it, make it a little bit skinnier, a little bit more narrow. So as I plot these last couple points, negative 1, 1, positive 1, 1, downward facing, again, a little skinnier than what we're used to, but that would be your parabola. And again, throwing this on here, domain and range. Our domain, still all reals, negative, positive. The range, since it is downward facing again, it starts at negative infinity and works its way up to the vertex, which is up here at 4 on the y-axis. So that would be from negative infinity to positive 4. Okay? So there's everything all together for you guys. As usual, if you have questions, let us know. Otherwise, that is it. So good luck. Chapter 4 is over. All right, have a great day.